We are absolutely swimming in data these days. It's everywhere. But how do we make any sense of it? Well, today we're going to dive into a really cool algorithm that finds hidden patterns in what looks like total and complete chaos.
So, picture this. You're a data scientist, and you've just been handed this massive data set. Thousands, maybe even millions of data points. But here's the catch. No labels, no categories, nothing. Where do you even start? How do you find the meaningful groups in that sea of information? It's a huge challenge.
And this is what that raw data usually looks like. Just a big cloud of dots scattered all over the place. Right now it's pure chaos. You look at this and think, are there groups in there? Are some of these dots related to each other? It's pretty much impossible to tell just by looking. And this right here is the exact problem that we're going to solve.
But here's the thing. Inside all that noise, there are almost always patterns just hiding in plain sight. We just need the right tool to pull them out and make them visible. And that tool, believe it or not, is a surprisingly simple but incredibly powerful algorithm called k-means clustering.
So what exactly is k-means? Okay, the best way to think about it is like an automatic sorting machine. Imagine you pour in a giant box of mixed up fruit. This machine, all on its own, will start sorting them into different bins. One for apples, one for oranges, one for bananas, and it does this without you ever telling it what an apple or an orange looks like. It just figures out which things are most similar to each other. That, in a nutshell, is k-means.
All right, so how does this magical sorting machine actually work? It's not magic at all. It's actually a really elegant and logical process. So let's pop the hood and take a look at the simple steps k-means uses to bring order to all that chaos.
It really all boils down to these 4 key actions: initialize, assign, update, and then repeat. This is what we call an iterative process, which is just a fancy way of saying the algorithm does these steps over and over and over, getting a little bit smarter with every single cycle.
First up is initialize. The algorithm literally starts by making a guess. It just randomly drops a few starting points. We call these centroids. And you can see them here as the red stars right on top of our data. And believe it or not, this totally random start is a super important part of the whole process.
Okay, now this is where the fun really begins. In the assign step, every single data point looks around and finds its closest centroid. Then, in the update step, each of those centroids moves to the dead center of the new group of points it just collected. And that cycle, assign, update, it just keeps repeating until the groups are so stable that the centroids stop moving. And just like that, here's our result. That chaotic mess of dots we started with, it's now beautifully organized into 3 distinct color-coded groups. The algorithm found the natural structure all by itself, and you can see the final centroids, now as red triangles, sitting perfectly in the middle of their clusters. Pretty cool, right?
So that's the how, but why should you care? What's the big deal? Well, this isn't just some abstract concept for data nerds. K-means is a total workhorse algorithm that's being used all around you, every single day. Let's look at a few examples.
For businesses, k-means is an absolute game changer for understanding customers. They can take all their sales data, who buys what, when they buy it, how much they spend, and let k-means group them into segments. You get groups like weekend bargain hunters, high-value loyalists, or one-time buyers. And this is exactly how they decide whether to send you a 10% off coupon or an ad for their new luxury line.
Over in the world of technology, k-means is everywhere. It's used for image compression, where it groups pixels with similar colors together to make file sizes smaller. It's also a great detective for finding anomalies. See, if a data point doesn't fit neatly into any cluster, it stands out. That outlier could be a glitch in the system, or it could even be a fraudulent credit card transaction trying to hide in the noise.
And what about all the text online, all the articles, all the documents? K-means can sift through thousands of news stories and group them by topic automatically, separating sports from politics from tech news. And that same exact logic is what powers so many recommendation engines. If you watch a movie in one cluster, chances are you're going to like the other movies in that same cluster.
Now, I've been talking it up a lot, but let's be real. As powerful as k-means is, it's not a silver bullet. It's really important to understand its limitations so you know when it's the right tool for the job.
The algorithm's biggest weakness is that it kind of assumes all the clusters are going to be nice, round, meatball-shaped blobs that are all roughly the same size. It's fantastic when your data looks like that. But if you throw it a curveball, like clusters that are long and thin, or shaped like a crescent moon, it can get really confused and draw the lines in all the wrong places.
And beyond the shape, there are a few other tricky parts. First, you, the human, have to tell the algorithm how many clusters to look for. That's the K. If you pick the wrong number, you're going to get garbage results. Also, because it starts with that random guess, sometimes it can get unlucky and find a decent solution, but not the best one. And finally, just a couple of extreme outliers can actually drag a whole centroid off course, messing up the entire group.
But hey, even with those limitations, you cannot deny the fundamental power of k-means. It gives us a simple, super efficient, and pretty intuitive way to do something that is, frankly, extraordinary.
It takes that giant, messy, unlabeled cloud of data that we started with, and it transforms it. It gives it structure. It creates organized, meaningful groups that we can actually understand and analyze. It finds the hidden story in the data, all without us having to give it any hints.
This quote right here just sums it all up perfectly. The whole point is to draw circles around groups of data points so that everything inside one circle is really similar and really different from the points in all the other circles. It's all about maximizing similarity within groups and maximizing differences between groups. It finds the signal in the noise.
So now you know. The next time you get a product recommendation that feels spookily accurate, or you see a news app perfectly sorting stories by topic, you'll have a good idea of the kind of elegant logic that might be working behind the scenes. It really makes you wonder, doesn't it? What other hidden patterns are just sitting out there in all the data that surrounds us, just waiting for the right algorithm to bring them to light?